All right, Algebra 2, this is LFR1, slope and rate of change, quick quiz 2. Let's do the key real quick. Our goal is to find the rate of change / slope with a line containing the pair of points, simplify any fractions, do not convert to mixed numbers or decimals. Okay. Slope, the equation is m equals y2 minus y1 divided by x2 minus x1. I've got 2 points on here, and if I do these, this is like an x1, y1. This could be treated like an x2, y2. So my slope would be m equals 16 minus -5 divided by 4 minus 2. Minus negatives plus a positive, this is 21 divided by 2. Now, simplify any fractions. That can't be simplified. Do not convert to mixed numbers. Check. Do not convert to decimals. Check. 21 halves. That is the correct answer. That's the solution. That's how I want it to see it. Okay. Number 2, x1, y1, x2, y2. M equals -6 minus 4 divided by 5 minus 3. I've got -6 and I go 4 more negative. I'm going to end up at -10. 5 minus 3 is 2. I can simplify that. -10 divided by 2 is -5. There we go. Fractions, Mr. Brayman, fractions. x1, y1, x2, y2. M equals 1/12 minus 1/12 divided by 1/3 minus 1/6. The top, 1/12 minus 12, simplifies to 0. Yeah. The bottom simplifies to -1/3, but that doesn't even matter because it's the top is 0 divided by a number that's not 0. 0 divided by anything means 0. That is our slope. Our slope is 0. All right, let's see what we got here. We can do 2 things here. We can do 2 different things here. We could do the slope formula. We could also do the rise over run, right? They'd come out the same. If I treat this as x1, y1, and x2, y2, x2, y2, this would be -8 minus 7 divided by 2 minus -4. Minus negatives plus a positive. -15 divided by 6. I can simplify those, divide both by 3. -5 halves. Notice how there's no mixed numbers or decimals. If I thought about like this, I can see this goes down 15 and to the right 6. Down 15, right 6. Or you could have gone up 15 and left 6, which should have been 15 divided by -6, still simplifies to -5 halves. Part E. Ooh, interesting. So if I did this, if I call this x1, y1, and x2, y2, this would be -2 minus 9 divided by 5 minus 5, -11 divided by 0. Anything divided by 0 in a fraction, if the 0 is on the bottom, this is undefined. You cannot divide by 0. Undefined. Now the other way, that's a vertical line. That's a vertical line. We know for a vertical line the slope is undefined. There you go. Fair enough. That could have been an answer, or a way to answer that one also. Backside, here we go. The table shows the cost in dollars charged by an electric company for various amounts of energy in kilowatt hours. Graph the data and find the rates of change. So 0 energy costs $8, so somewhere right around in here. 200 also costs $8. 34, I'm sorry, what we got? 400 goes to 34, somewhere about in here. 600 goes to 60. 1,000 goes to 112, about right here. And then 2,000, let's see, 12, 14, 16, 18, 2,000 goes to 157. Right about there. Compare the rates of change for each interval. Are they all the same? Well, our rate of change, this is where the mistakes have been made because you found the difference in y's but then forgot to divide it by x. So if I kind of drew the line in here, so the rates of change between 0 and 200 kilowatt hours, the y values change 0, the x values change by 200. This is 0, a 0 rate of change. The next one we have, 34 minus 8 is 26, divided by 200. We could simplify that, can divide them both by 2. This is 13 over 100. If I go from 400 to 600 right here, so this is 26 over 200, or 13 over 100. From 600 to 1,000, I go from 112 to 60, so that is 52 out of 400. You'll notice here, that's just double, right? This will also simplify to 13 over 100. Our last one is 1,000, a change of 1,000 in x gives us a change of 45 in y, so 45 over 1,000. If we simplify that, we can divide both things. Well, let's see, divide everything by 5. The top would be 9. Divide the top, or that by 5, I get 200. So there we go. We've got the rates of change. Are they all the same? No. 0 and 200. So between 200 and 1,000 are the same. 200 to 1,000 are the same. But 0 to 200 and 1,000 to 2,000 are different. Okay. What do the rates of change represent? Well, rates of change are the change in y divided by the change in x. So change in y, change that delta y, delta x. The change in y represents a change in cost. The change in x represents a change in energy. So the cost per kilowatt hour. That's the change. I just wrote that backwards. Kilowatt hour. The y divided by the x, the change in y divided by change in x. Describe in words the company's electric billing, the electric company's billing plan. This is a 4-level. This is a 4-level question, right? So essentially, you're going to get charged. There's no change. There's like this base charge between 0 and 200. So a base charge between 0 and 200 kilowatt hours of $8. And then between 200 and 1,000, so between 200 to 1,000, it is $13 per every 100 kilowatt hours used. Your change in y compared to the change in x. It is $13 per, there's your slope, 100 kilowatt hours used. Then after that, so 1,000 to 2,000, it becomes $9 for every 200. And if you're thinking about it, if you want to compare it to this up here, to the previous one, if you divide them both in half, this would be 4.5 per 100 kilowatt hours. So there would be quite a bit less than the 200 to 1,000. 1,000 to 2,000 is $9 for every 200 kilowatt hours used. Now, if you wanted to take that down and get it down to, if you took it down to a decimal, I could understand that. That's one of those cases where you might be able to and have it make a little bit of sense. If you did that, that's fine too. We can talk about that. If you have any questions, let me know. Otherwise, have a great day.